An extraordinary phenomenon has just unfolded in the universe of astronomy. The interstellar object, designated 3I Atlas, has become the focal point of a discovery that has left both researchers and space enthusiasts in awe. On November 9, 2025, astrophotography specialist Frank Nebling captured an image revealing a radiant, extended tail accompanied by a surprising ejection stream aimed directly toward the Sun. This photograph showcases a complex architecture never before documented in visitors from beyond our solar system, rekindling the mystery surrounding 3I Atlas. This remarkable observation coincides with the publication of a new article by Dr. Avi Loeb, a renowned astrophysicist from Harvard University, titled "The Impressive Large-Scale Structure of the Anti-Tail and Ejection Streams of 3I Atlas," released on the Medium platform. In it, Loeb examines the comet's unusual ejection configuration and raises unprecedented questions about its true nature. Is this merely a conventional interstellar comet? Or could it be something far more advanced, a self-propelled technological vessel? Importantly, Dr. Loeb is not making baseless speculations. His hypotheses are rooted in data. While he acknowledges that 3I Atlas may exhibit behavior typical of a natural comet, its acceleration, unusual brightness fluctuations, and now the emergence of multiple tail structures warrant thorough scientific scrutiny. The photograph captured by Nebling is stunning. It reveals two prominent features. 1. A luminous, fan-shaped anti-tail projecting away from the Sun. 2. A more slender, concentrated stream angled directly toward the Sun. This configuration has puzzled astronomers. Traditionally, comet tails always point away from the Sun due to solar radiation pressure and solar wind. Observing an ejection oriented toward the Sun is extremely rare and typically indicates localized and intense surface activity. The anti-tail, in particular, appears to span millions of kilometers into the vacuum of space. Its appearance results from a unique alignment between the comet, Earth, and the Sun. Occasionally, when Earth crosses a comet's orbital plane, the debris tail can appear inverted, an optical illusion. However, in this case, geometry alone does not fully explain the phenomenon. The image clearly shows multiple distinct streams. This is not just a visual trick. Why this discovery matters. Atlas is an interstellar object, meaning it originates from beyond our solar system. It is only the third such visitor ever detected, following Oumuamua in 2017, which showed anomalous acceleration without a tail, and 2I, Borisov in 2019, which behaved more like a standard comet. Atlas, intriguingly, appears to combine elements of both, exhibiting visible activity along with peculiar ejection structures and non-standard dynamics. The astronomical community has been closely monitoring 3I Atlas since mid-2025. It has already defied expectations, showing mild acceleration after solar perihelion, emission of radio signals, detected by South Africa's Meerkat radio telescope, which were compatible with hydroxyl molecules, evidence of water vapor released from heating. But now, the latest images reveal something entirely new: a large anti-tail and an ejection pointed directly at the Sun. Dr. Avi Loeb's analysis. In his recent analysis, Dr. Loeb explains that if 3I Atlas is entirely natural, the sunward ejection could be caused by asymmetric heating of surface ices. When sunlight hits these regions, it causes sublimation, releasing gas and dust at high speeds. If the comet is rotating irregularly, these ejections may briefly be directed toward the Sun. However, if the orientation of the ejections shifts in a way inconsistent with rotation or surface heating, this may point to phenomena not yet understood. Loeb clarifies that such behavior doesn't necessarily mean the object is artificial, but it does demand further investigation. As part of the Galileo project, Dr. Loeb and his team have long focused on distinguishing natural interstellar objects from potential technosignatures. He also emphasized that a second object recently identified, C2025V1, is not related to 3I Atlas. Despite being located between the comet and Earth, its orbital path is completely different, unless Atlas has propulsion capabilities, for which there's no direct evidence yet. The two objects are unrelated. December 2025. A rare opportunity. Atlas is drawing closer to Earth and will reach its closest approach in December 2025, offering astronomers a rare observational window. Upcoming investigations include the Very Large Telescope, ESO, and NASA's Hubble Space Telescope will capture high-resolution imagery. The James Webb Space Telescope may study its infrared spectrum to search for organic molecules. The Juno probe, currently orbiting Jupiter, will direct its radio sensors toward the comet in March 2026, during a close pass, an opportunity to confirm whether it continues emitting radio signals. What makes this comet unique? The antitail, seen in Nebling's image, is composed of microscopic dust particles reflecting solar light, forming a vast, fan-like structure. The sunward ejection, by contrast, appears gas-rich, dominated by carbon monoxide and traces of ammonia, a composition that differs slightly from typical solar system comets, which often contain higher amounts of water ice. This dual activity, dust and gas forming crossing tail structures, is extremely rare and has never been seen before in an interstellar object. Theories and questions. Several factors continue to spark debate. 1. Sunward ejection persistence. Normally, solar wind would quickly push such an ejection away. But here, the stream remains sharp and intact, suggesting exceptional energy or unusual material density. 2. Anti-tail symmetry. The debris tail aligns almost perfectly with the orbital plane, indicating remarkably stable rotation, a rare feat for a 100 km object. 3. Acceleration after perihelion. Atlas showed measurable acceleration post-solar approach. Could this be from natural outgassing or something else? Final thoughts from Dr. Loeb. Dr. Loeb reminds us that science requires following the evidence, no matter where it leads. Whether 3I Atlas turns out to be purely natural or something more, we are learning about interstellar travel, the composition of distant systems, and the conditions under which material survives across cosmic distances. He recalls that Oumuamua's acceleration remains unexplained to this day. But this time, we have better tools, better timing, and a second chance. A living laboratory among the stars, 3I Atlas, now moves through the inner solar system, its glowing tail stretching millions of kilometers, carrying with it ancient material from another star. From its nucleus, streams of gas erupt in opposite directions, one toward the sun, one toward deep space. Astronomers around the world track its nightly transformations. In December, amateur stargazers with intermediate telescopes may spot it as a faint glow in the constellation Capricorn. Professional teams will analyze its spectrum for rare isotopes, providing further confirmation of its interstellar origin. Thank you for watching. If you enjoy exploring the cosmos through evidence-based storytelling, be sure to like this video, subscribe to our channel, share it with fellow space enthusiasts. Together, let's keep watching the skies.